Hi, welcome everyone. Welcome to this course, Statistical Introduction to Statistical Mechanisms of Non-Active Systems. So far we have studied all the systems, random flight, Brownian motion, and also like focal length equations, diffusion equation, all these things. So in this coming to lectures, we'll solve few problems. We have solved or we have actually addressed few problems regarding random flights. So let's starting with some problem in Brownian motion and all the uh, more regarding stuff. Okay, so let's start then. So basically the first problem says, let me write, solutions of some problems. Okay, so the first problem says that problem 1 says consider a colloidal particle of radius 0.1 micrometer and density of the particle is 2 gram per centimeter cube, moving in water. Water has density 1 gram per centimeter cube and viscosity 1 millipascal second. So and then answer the following questions. Answer the following questions. So the question 1 is calculate the sedimentation velocity, it's a Vs of the particle. P is calculate the diffusion constant d of the particle and calculate the average distance which Vst that the particle moves in time t and its fluctuation root over dt for t is equal to 1 millisecond, 1 second, 1 hour, 1 day. So there are 4 different time scales, and discuss when we need to consider Brownian motion. Brownian motion. Now let's solve it. Okay. So let me write the properties. So eta is 10 to the power minus 3. 1 millipascal means 10 to the power minus 3 Pascal into second. A is 0.1 micrometer means 10 to the power minus 7 meter, and delta rho is the difference between these two. So rho p minus rho w is 1 gram centimeter per centimeter cube. Okay, and we know the gravitational acceleration is 9.8 meter per second square. Okay, so if that is the case, then it will be when this mg will balance mg will balance the gamma a gamma gamma v, and this v is the sedimentation velocity. Okay, so if you write this mg, and there is the buoyancy force because there is in this so let me write this mg minus buoyancy force, mg minus buoyancy force, so that will be 4/3 pi a cube. This is the volume of this, and rho w, rho p minus rho w, that is delta rho, that will be gamma v, that means 6 pi eta a vs. Now if you solve it, then it becomes vs becomes 2 by 9 pi a cube, 2 by 9 pi cancels out, so 2 by pi a cube delta rho, so there will be a g, delta rho g divided by eta a. So if you solve it, then it becomes 2.2 times 10 to the power minus 8 meter per second, or in micrometer unit this will be 0.022 micrometer per second. So you see the speed is so small, so very small sedimentation velocity. Okay, now the diffusion formula for the diffusion coefficient is, now we have to consider diffusion coefficient. Now formula, let me write this. So formula for diffusion coefficient D, that becomes kbt by 6 pi eta a, kbt by 6 pi eta a. That makes, if you substitute, so temperature, let's take temperature in the room temperature, and that becomes 2.2 into 10 to the power minus 12 meter square per second. That makes 2.2 micrometer square per second. Okay, now if you see that distance by which the Brownian motion moves is, let's say this is t, this is the average distance vst, and this is dt root dt. So if you start with 1 millisecond, then if you substitute the value of the sedimentation speed and other things, then it will come about 2.2 picometer, and dt will be 47 nanometer, and for 1 second this will be 22 nanometer, and this will be 1.5 micrometer, and for 1 hour this will be 78 micrometer, 89 micrometer, and for 1 day this is 1.8 millimeter, and this is 0.43 millimeter. So you can say that on an average, when t is more, you can consider this as Brownian motion. Okay. Okay, so let's solve another problem. This problem says, problem 2 says, calculate the mean square displacement of the free Brownian particle, using the formula or lessons taught in the class, and show that and so that the formula of MSD, that is 2dt, is true for t very greater than tau. Okay. Okay, solution. So let's say x of t minus x of 0 whole squared, that becomes 2 0 t dt1 0 t dt2 into kbt by m e to the power minus t by tau. So to the power minus t by tau. Now if you solve it, then we have solved it. It becomes, please refer the lectures, 2bt by gamma into t minus tau v into 1 minus e to the power minus t by tau v. Okay, so now for equation 1, if we take t very less than, sorry, very greater than, very greater than tau v, that makes t by tau v very greater than 1, then it becomes e to the power minus t by tau v tends to 0. So xt minus x naught whole square becomes 2 kbt by gamma, so this will be d 2d t minus tau v. Now see, t is very greater than tau v, so this becomes 2 dt. So from here we can say that this becomes like the Brownian motions from its in square displacements becomes 2 dt for the time for the time lag values, or for the time scale when it is very greater than velocity autopolarization time scale. Okay, so so this is pretty simple. This can be followed from the lecture. Now problem 3. The Langevin equation, the Langevin equation for the Brownian particle, in a harmonic potential, is solved for position xt as x of t is equal to minus infinity to t dt1 e to the power minus t1 about or tau vr of t1. Let's say this is equation 1. Now answer these things. Calculate x of t whole square using velocity autocorrelation of random force and show that and show that it is equal to kbt by k. Second thing is calculate time correlation function x of t and xt prime for t greater than t prime and t less than t prime to different regime. And third, calculate xt random velocity vr0 for t greater than 0, t is equal to 0 and t less than 0. So one thing is here that time reversal symmetry is not maintained by this expression. Okay, so you cannot say from t greater than 0 it will be same as t less than 0. So because xt 0 does not hold time reversal symmetry, calculate x0 using the lectures given. Okay, so now let's solve it. Okay, so basically what we will do, first say a x of t squared and its average will be minus infinity to t dt1 minus infinity to t dt2 e to the power minus t minus t1 by tau into e to the power minus t minus t2 by tau into average of random velocity vr t1 vr t2. Okay, now this is, we know what this is. This is 2d delta t1 minus t2. So then this becomes minus infinity to t dt1 minus infinity to t dt2 e to the power e to the power minus t minus t1 tau to the power minus t minus t2 by tau 2d delta t1 minus t2. Okay, so now let's use this thing. So for the first thing, since this is delta function, we need to do it for this. So 2d comes out, it becomes minus infinity to t dt1. So for this thing dt2, it will be minus t minus t1. So this will be to the power minus 2 of t minus t1 by tau, right? Only just this t2 will be replaced by t1. Okay, so basically this is this term. Now if you do this in calculations, then it becomes 2d 2d into tau by 2, 2d into tau by 2 into minus e to the power 2 minus t minus t1 by tau. Okay, 2 minus t minus tau 1, and it is minus infinity to t. Okay, now so minus minus plus, so this will be t. So there will be no minus because this is t1 minus t. T is constant. So when t is equal to t, then this will be 0, that means 1. For minus infinity, this will be 0. So this will be dt. So this will be d tau. Okay, so now tau is d into tau will be gamma by k, and this is d is kbt by gamma, and tau is gamma by k. That cancels out and it brings kbt by k. K is stiffness constant, since d is equal to kbt by gamma and tau is equal to gamma by k. So this term done. Okay, so a is done. Now we are told to calculate the time correlation function. Okay. Calculate time correlation function. Okay, so then should write xt prime is equal to minus infinity to t dt1 minus infinity to t dt2 e to the power minus t minus t1 by tau to the power minus t prime minus t2 by tau, and this guy, then it will be t prime t minus delta over delta t1 minus t2. Only thing is here the limit will be t prime. Okay, now we will sort of play around this expression. Okay, so we will play around these expressions, like let's say this equation 2. Now for t greater than t prime, t is greater than t prime, integral over t1 would produce would produce xt prime 2d minus infinity t prime dt2 and t2, it will be as usual, only thing is t1 will become t2, right? So then this will be t2 minus t1 and this will be t minus t1 as usual, right? So this becomes then e to the power e to the power because it will be for those value where, because this one for will be for those values when it is in that region. So let's say z t prime t and t prime, for that the delta integration will be done. So dt2 minus t minus t1 by tau times e to the power minus t prime minus t1 divided by tau. Okay, so now if you integrate it, sorry, so this will be T2 because T1 will be replaced by T2. Okay, so then it becomes is equal to this e to the power minus t prime will be outside. T minus t prime, so 2d e to the power minus t plus t prime tau time minus infinity to t prime dt2 e to the power 2t2 by tau. Now if you do the integration, then it becomes dt 2d into tau by 2 into e to the power minus t plus t prime by tau into e to the power 2t2 by tau, where t2 becomes minus infinity to t prime. So minus infinity becomes 0, only t prime remains, so that becomes d tau into e to the power minus t plus t prime by tau times e to the power 2t prime tau, and that makes this integral to be equal to d tau e to the power minus t minus t prime by tau, because there will be minus t prime will be there, so that will be this thing. So for t greater than t prime, this is this example. Now similarly, if you do this for t less than t prime, then the integral over t2, so then this integral needs to be done first, this one. So if you do that, what t2 will give x of t prime x of t prime will give you is equal to 2d minus infinity to t prime dt2 e to the power minus t minus t2 by tau into e to the power minus t prime minus t2 by tau. Okay, so now similar way we will take this out, 2d times e to the power minus t plus t prime by tau. So but here this will be t, this will not be t prime, this will be t. Okay, t prime times minus infinity to t dt2, sorry, dt1, this will be dt1, this will be dt1, because we have integrated out the delta function for t2, right? So then this will be dt1 times e to the power 2t1, so t1 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 tau. That makes it 2d times e to the power minus t plus t prime by tau times e to the power 2t by tau. That makes it 2d into e to the power minus t prime minus t by tau. See, there is some difference, so you can then write, so it will be like t prime minus t means mod of these things, so hence to combine both these results, we should write x of t prime x of t prime and its average is equal to dt. Okay, sorry, there will be tau by 2, then it becomes d tau e to the power minus, and d tau is kbt by gamma, so now we will write this t minus t prime mod by tau, and this is kbt by k, t minus t prime by tau. Okay, so now third question, it says calculate this correlation of xt vr 0 for 3 regions. Okay, so to do that, what we will do, we will this that this is c so xt vr of 0, that becomes minus infinity to t dt1 e to the power minus t minus t1 by tau into 2d delta of t1. So that should be the case. Now think about what should be the for 3 regions. So think about it. I will give you 2-3 minutes. So think about it. So basically what you have to do, you have to think that what should be the approximations for this relation so that we can use two different regimes. Huh. It just requires the relation of delta functions. See, the delta function is for infinity for t1 is equal to 0 and and it is 0 otherwise. So then you have to use it, you know, astutely. Huh? Okay. So now basically when you are talking about two three parallel regimes, so for for t greater than 0, it becomes, this expression becomes t1 equal to 0. So if t1 equal to 0, it will be substitute here and it will become 2d e to the power minus t by tau. For t is equal to 0, for t is equal to 0, basically this becomes 0 to minus infinity to 0 delta t1 dt. That makes dt by half and d. And for t less than 0, you can write that since it is outside this regime 0 to t, so it probably becomes 0. Okay, so that is the case. Okay, so now question number 4. We are required to calculate these relations using our different relations given in the lectures. Okay, so basically we were given that x dot t, x dot 0, and its average was minus, you can calculate its average by taking minus del 2 del t2 x of t x of 0. Okay, then you can write if you remember there was this relation that what was this relation? This relation was e to the power minus mod t of tau, so then it will be minus kbt by kappa, sorry, del 2 of e to the power minus mod of t by tau. Now this e to the power minus mod of t, that can be written as follows: minus kbt by k del 2 del t2 using theta function theta of t e to the power minus t by tau plus theta of minus t into e to the power t by tau. Okay, so we can sort of define these two regimes. So now we have to use two formulas. Now derivative of theta function is delta function. So ddt of theta t is equal to delta t. And also remember one thing, that f of t dd of delta t dt, that becomes minus of delta t df t. Now if you use this formula, then for there can be two things. Okay, so now use this thing. So for first thing, ddt of theta t of e to the power minus t by tau plus theta of minus t to the power t by tau. So for first thing, this will be delta t e to the power minus t by tau, and this will be delta so delta function is even function delta t, but there is a minus, so minus e to the power t by tau plus minus theta t to the power minus t by tau into tau plus theta of minus t to the power t by tau by tau. So these two things becomes from here. Okay. Now again we need to calculate these functions. Now let's say this is a. We need to take differentiation again with respect to t of expression a. Okay, so we have to take the expression differentiation again. So for that, then it becomes for first thing ddt of delta t to the power minus t. So this for this thing, first thing it will be minus delta t to the power minus t by tau plus using this formula for here. So if you take e to the power minus ddt of delta t, so it will be minus delta t minus delta t minus delta t of df dt. So df dt means e to the power minus t by tau of minus tau. Okay, so then these two cancels out. These two cancels out. Similarly here for the first thing, this will be minus delta of t e to the power t by tau, and this will be minus, so again ddt of delta t, that will again makes this, so delta t df dt t by tau. So for these two terms, there will be no expressions. Now again, if you think about this term, this will be minus delta t to the power minus t by tau. Again minus minus plus, so theta t e to the power minus t by tau and tau squared, because there will be one extra tau here. Similarly here this will be delta t minus delta t minus delta t so to the power tau by t by tau. So here first term becomes delta t minus delta t e to the power t by tau, tau square, sorry tau, and then theta of minus t e to the power t by tau, tau square. So it then becomes kbt by tau, tau, tau square, so gamma square by x square. So tau is gamma by k square cancel out, kbt by gamma. Okay, so okay, now this two thing is we need to use so now for these two terms make 1 by tau square theta t e to the power minus t by tau plus theta of minus t e to the power t by tau. That makes it 1 by tau square e to the power mod tau by tau minus mod tau by tau minus mod of t by tau. So if you substitute by this thing, so from here, and now there will be 1 tau square, so one term will be then from here, so kbt by k minus into 1 by tau square, that makes minus kbt by k. 1 by tau means k by gamma into 1 by tau, that makes it kbt by gamma means minus d by tau. This terms, from this term there will be one term is minus d by tau to the power minus t by tau, and for only for this it will be only for those expression there will be 2 minus delta t by tau. Now this, as t increases, it becomes so this. Now this term, the since delta t is 0 for any values other than t is equal to 0, so only term that will contribute for e to the power minus t by tau is 0. So then minus delta t e to the power minus t by tau becomes minus delta t by tau. Similar this one, minus delta t e to the power t by tau becomes minus delta t by tau, because that should be the value limit t tends to 0. Then from these two terms it becomes, so from these two terms the contribution comes to be minus 2 delta t by tau. Now you have to multiply with minus kbt by k. So now minus kbt by k into minus 2 delta t by tau, that makes it tau is gamma by k. So kbt by k into k by gamma into 2 delta t. So k cancels out and remaining part is kbt by gamma into 2 delta t, and kbt by gamma is 2 delta t. So this part is, so now from those two parts it's become x dot t x dot 0, it becomes 2d delta t minus 2d delta t minus d by tau e to the power minus mod of t by tau. So this is the final expression. So we have proved it. So what we have done here, basically, if I review this problem because there is laborious calculation. So actually this autocorrelation is del 2 del t 2 e to the power minus mod t by tau, right? Now this mod function can be written in terms of theta function. So when t is greater than 0, it can be written as theta t e to the power minus t by tau because it is absolute function. And when t is less than 0, then it can be written as theta of minus t, that means 1. Theta of minus t is, so let me write it here, theta of t is equal to 1 for t greater than 0 and 0 otherwise. Similarly, theta of minus t is 1 for t less than 0 and 0 otherwise. Okay, now if you think about it, so that's why you have written this. Now here we have used few things for our calculations. One thing is, if you take the differentiation of the theta function, that becomes this delta function, right? And if you take like this a function and then times delta function's derivative, then it becomes minus delta t df dt, minus delta t df dt. So now what we have done, so we are calculating the first derivative. So for first time, if you differentiate it, so for theta t it is become delta t, and it is as usual. So it is like product of two function, so one by one. And again for this will be delta t, since delta function is given function, and for minus t this is minus e to the power t by tau. And for this when you are differentiating this thing, then it will be e to the power minus t by tau is e to the power differentiation of e to the power minus t by tau, e to the power minus t by tau, and there is minus. And similarly this will be theta t minus t e to the power t by tau. Now again we have to differentiate with respect to this expression because there is double derivative. Now if you take double derivative for this, so for first expression this will be, for if you differentiate this exponential function, this will be minus delta t e to the power minus t by tau. And if you differentiate this, here we will use this function. So since this is dt of delta t, so it becomes minus delta t times del f del df dt. So uh, differentiation of this function, and differentiation of this function is minus of e to the power minus t by tau into minus t. So this will plus and this is minus, so that's why it cancels out. Similarly for this, when you are differentiating with respect differentiating this function, this become minus delta t e to the power t by tau into tau. And when you are differentiating this becomes minus of that, so minus minus plus, and delta t e to the power t tau by tau, right? So then you will get this, and so this two cancels out. And for this, for first time if you differentiated theta t, then it becomes delta t, so delta t and e to the power minus t by tau. In next term e to the power minus t by tau, there will be e to the power minus t by tau by 1 by tau, so there will be minus minus plus, so tau square. Similarly here this will be theta minus t e to the power t by tau square. So we club them together here. So this function then can be written as 1 by t square e to the power minus mod t by tau. Now there is one minus k by t by k prefactor. So if you multiply this, so tau is, we know tau is gamma by k. In our lecture please follow that. So this will be minus k by t by k 1 by t square. So I have just written 1 t tau as gamma by k, and after writing that like this, we can get k cancels out and kbt by gamma is d, so it becomes minus d by tau. Similarly, now for these two things, this and this, we can write that delta t is equal to 0 for any value other than t equal to 0. So that's why we have to substitute for t is equal to 0. If you substitute for t is equal to 0, this becomes minus 2 delta t by tau, and minus 2 delta t by tau times kbt by k. So this is minus minus positive, so this becomes 2d delta of t. So that's why you can easily write these expressions. And we can get this whole expression that was we have assumed in the lecture video. Okay, so we will stop here, and in the next class we will discuss some more problems to finish this course.